Activity selection problem. Let us first understand what is this problem all about. Suppose that we have a set of activities A1, A2 till AN. These activities may be printing a document, printing a document. It means that there are n number of users, all of them has a copy or has a document to print, and they have a common printer. This is called common resource or shared resource among all the users. Now for every user there is one activity, and these are the set of activities, and for these activities also there is associated start time and end time. For example, S1 indicates the start time of activity A1 and F1 indicates the end of that activity. Similarly, S2 is the start time of activity 2 and F2 is the end time of activity 2. The same way, Sn is the start time of activity An and Fn is the end time of activity An. Now, since this printer cannot be used by all the activities at the same time, that is why we have to select a subset of activities from S in such a way that none of these activities are overlapped. The problem is we have to select a subset of activities from S in such a way that the maximum number of activities could be completed. But however, we need to keep it in mind, if we select two activities AI and AJ from the set of S, then both AI and AJ should be mutually compatible. So what do you mean by mutually compatible? For two activities AI and AJ are said to be mutually compatible if the start time and end time of both the activities do not overlap. To better understand this problem, let's take one example. We have considered 5 activities A1 to A5. A1 starts at time unit 1 and it ends at time unit 3. For example, let's say this is the timeline and this is time unit 1, 2, 3, 4, 5, 6, so on so forth. From here to here, activity A1 is executed and A2 is executed from time unit 2 to 4. This is A2 is executed. Then A3 starts at 3 and ends at 5. This is A3. Similarly, A4 and A5, A4 and A5. Out of these activities, if we split into different subsets, A2 and A4 can be one subset which could be used for execution, because A2 starts at 2 unit and ends at 4 unit time, and after ending of A2, A4 started. But however, if we select two activities A1 and A2, A1 starts at time unit 1 and it goes till time unit 3. A2 starts at time unit 2. That's why these two A1 and A2 are overlapping. A1, A2 cannot be taken for execution. Now here we need to find out the maximum subset. The maximum subset in this given problem is, we can select A1, it finishes at 3 unit, then A3 started, it finishes at 5, and A5 started. So A1, A3 and A5 would be the maximum subset which can be executed. So this is actually the problem. We need to find out a way how to solve it. To solve this problem, there are two different methods. One is the greedy method and other one is dynamic approach or dynamic programming. In this video, we will discuss the greedy approach of solving this problem, and dynamic problem will be solved in later videos. To discuss the greedy approach of solving this activity selection problem, we are taking a problem with 11 activities starting from 1 till 11. The first thing we need to do is to arrange all these activities in the ascending order of their finishing time. So here activity 1 finishes at 4, 2 finishes at 5, and all the activities we have arranged in the descending order of their finishing time. Then this greedy approach will first select randomly an, an activity. Let's for example, we have selected activity A1. Then this is the finishing time of activity A1. We will select now the next activity who starts after completion of activity 1. In this case, I will go to activity 4 who starts at 4, and we will note down this activity here, note down this activity A4. So A4 could be selected. If I look at this table, if I look at these various activities, A2 is not compatible with A1 because it does not finish before starting of activity 2. So A1 and A2 are not compatible, not mutually compatible. That's why when we select A1, we cannot select A2. But however, A4, activity A4 starts after completion of activity A1. That's why we can select A4. So A4 is now part of this subset. Then we will, after that, we will go to the next activity when this activity 4 ends. I mean, who starts after activity 4 ends. If I go to this activities, then we can see 6 item or activity 7. Up activity 7 starts when activity 4 ends. So we will select that activity A7. Then we'll go ahead in towards the end of these activities. Then we can see this is the 8 is the ending time of activity 7, and then it's 8 is started. So we can select activity A8, then it ends at 9. We'll go keep on going, and we can see 11, activity 11 is starting at 9. So activity 11 is also selected. So now the maximum set we have is A1, A4, A7, A8 and A11. 5, the 5 activities can be executed or selected for execution because all of them are mutually compatible activities. Now this is the way how this greedy approach of finding activity selection or selecting activities works. So now let us see the function for this activity selection. Let's see the function. This is the algorithm for activity selection in greedy approach. To implement this problem, we have taken one structure. The name of the structure is activity, and it has two fields. S stands for start time and Fi stands for finish time. So we have also created one array of activity structure activity. This is that array. It has 11 different locations, that is 11 elements are there. The first place, this is the data for activity 1, this is the data for activity 2, activity 3, so on so forth. The first, this is activity 1, and this indicates the start time of activity 1, this is finish time of activity 1. This is implemented as a structure, and this is that these are the values stored in this array. Moreover, the array activity, this array active, it stands for activity. This array is sorted with respect to the finish time. 4, 5, 6, then 6, 7, that way it is sorted. And now this algorithm starts with an array A n. This is the array. It has 11 locations for 11 activities. Initially the first place is set to 1, means that this activity is selected as a part of the maximum set of activities. So 1 is selected, that's why we mark it as 1. So that means activity A1 is selected in the set S. Our objective is to find the set S with maximum number of activities, and that is also all the activities in set S is mutually compatible. Now let's execute this code. It will start execution from with the value of k is equals to 1, and we already have set this value to 1, means activity 1 is selected. Then it starts the for loop. In the for loop it starts scanning the elements from 2, so it will go to this element and it goes inside the for loop, and inside the for loop what we are doing, we are taking the start time of any activity 2. Start time of activity 2 means here, since 1 is considered, 1 is selected, so we'll go to 2. I'll check the start time of this activity, and if the start time of this activity, currently selected activity 2, is bigger or equals to the end time of activity 1, then we'll select that activity. Here 4, it is 4, and into the start time is 3, so we cannot select 2. We'll go to 3, it is 2, start time is 2, though that's why we cannot select 2 even. We'll go to 4, the start time of that activity is 4, and the end time of activity 1 is 4, so activity 4 will be selected. So I will set this activity 4 set to 1, we'll set it to 1, then I will come out, it is set to 1. Then we'll make k is equals to j. K will be equals to j. So k will now point to, this is j. This is will be the new value of k. Then we'll come out of this for loop. We'll continue this at we'll continue the process. So we will again repeat. We'll go inside this loop. Now the value of k is 4. Value of k is 4. We'll start from 5. Then end time of activity 4 is 6. Then we look for any activity who starts at 6 or higher than 6. So if I look at in the table, all elements are not here, we'll go here, go to this table, and we can see here 6, activity 7 is started at 6, so we will select the activity 7. Then we'll go on scanning the activities in the structure, and 8 is selected, so 8 will be set to 1. Then 11 will be selected, so 11 will also be set to 1. So at the by the meantime, the value of j will be equals to n equals to 11 in this case. So it will complete the execution of the for loop. It will come out and it will return the value of a, or it will return the array a. In the array we can see activity a1 is selected, a4 is selected, and a7 is selected, a11 is selected, a11. This is the set of activities which can be executed, which are selected for execution. Let's have a look at the execution time of this algorithm. First of all, we need to arrange all the elements in ascending order, that is sorting of this array. So sorting of array, the execution time of sorting of array is can be at most better, it can be at most theta of log of n. This is the time required to sort the array of activities. Then after that we execute this function. This sorting is only one time process. After that we execute this algorithm, and in the algorithm we have a for loop, and this for loop executes for n time. That's why this execution time of this algorithm is order of n. And if we exclude, if we do not consider the sorting time of this algorithm, as it is done only once, so the computation time of greedy algorithm for selecting activities is order of n. So this is all about the selection of activities using greedy approach, and we can solve the same problem using dynamic approach also. So dynamic approach is not included in this video. We will discuss dynamic approach of selecting activities in a different video.